In this lecture, we get down to the nitty-gritty of what this course is really about, namely the construction of formal proofs. So let's start out by talking a little bit more about how to symbolize arguments. So consider the following argument once again. If it is raining, the streets are getting wet. It is raining, therefore the streets are getting wet. If we put the premises of this argument in terms of our logical notation, we get the following argument pattern. P arrow Q, P, therefore Q. Another way in which we could represent this argument pattern is as follows. P arrow Q, P, this little sideways T symbol here, Q. Alright, that little sideways T symbol there is called a turnstile. And you may think of it as meaning therefore. So you may read the above as follows. If P, then Q, P, therefore Q. An argument pattern represented in this way, the way it is at the top of this slide, is also called a sequent. Now the two sentences to the left of the turnstile, the two sentences on the left side of the sequent, represent the premises of our argument. The sentence to the right of the turnstile, to the right of the sequent, represents the conclusion of our argument. Now, as we've already seen many times now, the argument pattern represented above is valid. It's formally valid. But we're going to build a method of proving that this argument pattern, as well as other argument patterns that we can represent in our system, are valid. So let's get started on that task. So our current goal is going to be to write out a proof for this argument. That is, to write out a proof that demonstrates that this argument pattern is valid. And we will give these proofs by way of the inference rules associated with our system. And we're going to introduce these rules as we go along. We're going to gradually add to our stock of inference rules until we're able to represent all of the arguments that we want to represent in our system. Okay, we're going to start out with our first rule, which I'm going to call the rule of premises. The rule of premises tells us that we may at any time write down a line that contains one of the premises of the argument for which we are trying to write out a proof. Now remember, the premises of this argument are found on the left side of the sequent, on the left side of the turnstile. So the premises are P arrow Q and P. So using the rules of premises, we can get started on our proof as follows. We'll write down one line that has the first premise, P arrow Q. We'll write down another line that has the second premise, P. Note that each line of our proof so far is numbered. It is extremely important when you are writing out your proofs that you number each line. Note also that to the right of each line is the capital letter P. Here the occurrence of the capital letter P tells us which of our rules justifies us in writing down that line, namely the rule of premises. And I want you to, when you write out your own proofs, you'll always have to write down what it is that justifies you in writing down that line. Okay, your textbook does not introduce what I'm calling the rule of premises. This is an important difference from the way in which I'm doing things and the way that your textbook is doing things. Your textbook introduces what it calls the rule of assumption. Now this is not exactly how we are going to do things in this class. Unlike the author of your textbook, I prefer making a sharper distinction between the premises of an argument and any assumptions that might be made in the process of proving its validity. We will introduce a rule of assumptions later on, but we'll introduce it as a distinct rule from the rule of premises. So you are to do things the way I'm showing you how to do them in this lecture, not the way that your book tells you to do them. Okay, so here's what we have so far. There's our sequent. We were able to write down 2 lines using the rule of premises. Now our goal is to use our inference rules to write down lines until we're able to write down the conclusion of our argument as a line. In this case, until we are able to write down Q as a line. We don't have enough resources to achieve that goal here yet, though. So for that we need another rule. And that rule is Modus, Ponendo, Ponens, or as it's most commonly called, just Modus Ponens. So remember that if one has a conditional of the form if blank, then blank, the subsentence that goes in the first blank, right after the if, is called the antecedent of the conditional, and the subsentence that goes in the second blank, after the then, is called the consequent. So our rule of modus ponens, or modus ponendo ponens, tells us that if one has a conditional on one line and the antecedent of that conditional on another, one may write down a new line containing the consequent. Okay, so let's look at how that works. Here's what we have so far. We were able to write down the 2 lines containing our premises. On line 1 we have P arrow Q, so on line 1 we have a conditional. On line 2 we have P. Notice that P is the antecedent of the conditional on line 1. So the rule of modus ponens tells us that because we have a conditional on line 1 and because we have the antecedent of that conditional on line 2, we are permitted to write down the consequent of that conditional. So the antecedent of the conditional on line 1 is P. We have that antecedent on line 2. The consequent of the conditional on line 1 is Q. And since we have the antecedent of that conditional on line 2, we can write down the consequent of that conditional on line 3. Notice that to the left of line 3 I have written 1 and 2 to indicate the lines that I use to infer line 3, as well as MPP, that stands for obviously modus ponendo ponens. I've written that down to indicate the rule that justifies me in inferring line 3 from those lines. Note that it's very important that you do the same things when you write out your own proofs. If you infer one line from other lines of the proof, then you need to write down to the right of line 3. I apologize for that. That's a typo. I'll correct that in the slides that I post online. To the right of line 3, you must write down the 2 lines, or the numbers of the lines that you use to infer that line, as well as the rule that justifies you in inferring that line. Okay, let's look at a more complicated example. So consider this argument pattern. P arrow Q, Q arrow R, P turnstile R. Or reading this more in natural language, if P then Q, if Q then R, P therefore R. This argument pattern is valid, and the rules we have up to this point allow us to prove that it is valid. So how do we get started? Well, we're going to start out our proof of this sequent. We're going to start out our proof that this sequent is valid in the same way that we're going to start out any of our proofs, and that is to write down our premises. So on line 1 we write down P arrow Q, and we're able to do that because of the rule of premises. So over there to the right I write down P. On line 2 I write down Q arrow R, and over to the right I write P. On line 3 I write P, and over to the right I write P. So that's our premises written down. Now I am able, via the rule of, well, here, let me back up a second. So here we have our premises. Okay, now what do we do? How do I think about what to do next? Now my ultimate goal is to be able to write down R. But I'm not able to do that yet. So what can I do? Well, I notice that on line 1 I have a conditional, and on line 3 I have the antecedent of that conditional. So I notice that I could use the rule of modus ponens to write down Q. And given the rules I have so far, that's the only thing I can do. So when you're constructing a proof and you get stuck, try to find out what you can do. Sometimes you have very few moves to make, and that shows you the move you should make. So I'm going to go ahead and apply modus ponens and write down Q. And I inferred Q from lines 1 and 3 via modus ponendo ponens. Okay, so now I've got Q. Now can I do anything else? Well, now I can. So now that I've got Q, I notice that on line 2 I have a conditional, Q arrow R, and I notice now that on line 4 I have the antecedent of that conditional. So that allows me to apply the rule modus ponens again in order to get R. So now I have R, I got that via lines 2 and 4 via the rule modus ponens, and now I am done. So that gives you an example of how to write down a proof. I'm going to go ahead and have you do a couple of problems from your textbook so that you can get some more practice at this, and then we'll start expanding our system by adding more rules next week.